Welcome. Today we'll solve a complex titration problem involving aniline, a weak base used in polyurethane production. Let's break down the problem into three parts: finding the initial moles of aniline, calculating the equivalence point volume, and determining the pH at equivalence. Let's start with part A, calculating the initial moles of aniline. We use the formula moles equals molarity times volume in liters. With 0.280 molar concentration and 60.0 milliliters, which is 0.0600 liters, we get 0.0168 moles of aniline. For part B, we'll find the volume of HCl needed to reach the equivalence point. At the equivalence point, the moles of HCl equal the moles of aniline. We can set up the equation. 0.375 molar HCl times the volume equals 0.0168 moles. Solving for volume, we get 0.0448 liters of HCl needed. Finally, let's tackle part C, finding the pH at the equivalence point. At equivalence, all aniline is converted to its conjugate acid, C6H5 NH2+. First, we need to find Ka using the relationship Ka times Kb equals Kw. This gives us Ka equals 2.33 times 10 to the negative 5. Next, we calculate the concentration of the conjugate acid at equivalence, which is 0.160 molar. The conjugate acid undergoes hydrolysis. C6H5NH3 plus H2O gives C6H5NH2 plus H3O plus. Using the Ka expression and solving the resulting quadratic equation, we find that the pH at equivalence is 2.71. Let's summarize our results. The initial solution contains 0.0168 moles of aniline. The equivalence point occurs at 0.0448 liters of HCl, and the pH at equivalence is 2.71.